What exactly is dark matter? Let's drift together into the quiet mystery of the cosmos. Settle into stillness, close your eyes, and imagine floating weightlessly among the stars. Let your curiosity rise like starlight, soft and shimmering. Our journey begins with a question as old as the universe itself. What exactly is dark matter? Picture the night sky, the glittering galaxies, the swirling nebulae, the planets dancing in their orbits. But here's a secret. Everything we see, every star and speck of cosmic dust, is just 4% of the universe. The rest? A vast invisible realm. Dark matter, a ghostly presence, silent and unseen, holding galaxies together like threads of shadow. For centuries, humans gazed upward and wondered. But it wasn't until 1933 that a Swiss astronomer named Fritz Zwicky noticed something strange. Galaxies in a distant cluster were moving too fast, so fast they should have torn apart, flung into the void. Yet there they were, spinning gracefully. Zwicky whispered a hypothesis. Perhaps an unseen mass, dunkle materia, was binding them. The universe, it seemed, was keeping secrets. Let's unravel this gently. Imagine tossing a stone into a pond. The ripples spread outward, obeying the laws of gravity. Now picture a galaxy. Stars orbit its center, just as planets orbit the sun. But when scientists calculated the galaxy's mass based on the stars and gas we see, the math collapsed. The outer stars should drift away, lost to the darkness. Yet they cling, racing around the galaxy's edge as if gripped by an unseen hand. Dark matter is that hand. Invisible, intangible, it neither emits nor reflects light. It doesn't collide with atoms, nor dance with magnetic fields. Yet its gravity sculpts the cosmos. Like a cosmic architect, it weaves galaxies into vast webs, guides newborn stars into their orbits, and bends the fabric of space-time itself. We cannot see it, touch it, or hear it, but we feel its pull. Here's a wonder. Dark matter may be everywhere around you right now. Trillions of particles could be streaming through your body, gentle as moonlight, unnoticed. Scientists hunt for them in abandoned gold mines, deep underground, where sensitive detectors wait in perfect stillness. So far, silence. But the search whispers of human ingenuity and humility. In the 1970s, astronomer Vera Rubin peered into the hearts of galaxies and found proof of this hidden force. Her observations revealed stars orbiting at speeds that defied visible matter alone. Her work, once dismissed, became a cornerstone of cosmology. Today, we know dark matter outweighs ordinary matter 5-1. Without it, galaxies would vanish like smoke. The universe as we know it would not exist. But what is it? Theories glimmer like fireflies in the dark. Some say dark matter is made of WIMPs, weakly interacting massive particles, elusive entities born in the Big Bang's furnace. Others imagine axions, particles lighter than a whisper. Or perhaps it's something stranger, primordial black holes or hidden dimensions folding into our own. We do not know, and that's the beauty. Science thrives in mystery. For every answer, a deeper question unfolds. Dark matter reminds us that the universe is vaster, stranger, and more generous with secrets than we dare to dream. What might we discover in the next century? Could dark matter hold clues to parallel worlds or the fate of the cosmos itself? Let your mind wander now. Picture the Milky Way, its spiral arms glowing with starlight. Trace the invisible currents of dark matter cradling it, a cosmic embrace. Billions of years ago, those same invisible threads drew matter together, igniting the first stars. Without dark matter, there would be no planets, no oceans, no you or me. We are children of shadow as much as light. And yet, we share this universe with a substance we cannot comprehend. Does that unsettle you? Or does it stir awe? Perhaps both. For in the unknown, there is room not just for discovery, but for wonder. As our journey slows, let's linger on this thought. Dark matter is not a problem to solve, but a story to unfold. It invites us to look beyond what's visible, to trust in the gravity of the unseen. Every galaxy, every flicker of starlight hums with the presence of this ancient mystery. And somewhere in the quiet between questions, we find a deeper truth, that curiosity itself is a kind of light. What is dark energy, and why the universe is expanding faster? Let's wander through the velvet expanse of the cosmos. Settle into your quietest self. Close your eyes, breathe slowly, and imagine the universe not as a static canvas, but as a living, breathing entity, stretching, growing, evolving. Our journey begins with a question that hums in the heart of space itself. What is dark energy, and why is the universe expanding faster? Picture the universe moments after the Big Bang, a seething ocean of energy, particles flickering in and out of existence. For billions of years, galaxies drifted apart, carried by the echoes of that primordial explosion. But here's the mystery. Instead of slowing down, pulled by gravity's tender embrace, the universe is accelerating. It's as if the cosmos is exhaling, pushing itself outward with a force we cannot see, touch, or name. This phantom breath is dark energy. Let's unravel this gently. Imagine blowing up a balloon. With each breath, the rubber stretches, the surface expanding. Now picture every dot on that balloon as a galaxy. For decades, scientists believed gravity would act like a gentle hand, slowing the balloon's growth. But in 1998, two teams of astronomers made a discovery that rippled through science. Distant supernovae, the dying whispers of stars, were dimmer than expected. Their light stretched thin, not because the universe was coasting, but because it was racing. The expansion was speeding up. Something invisible was overpowering gravity itself. Dark energy is that something. It's not a substance, nor a particle, but a property woven into the fabric of space-time. Think of it as the anti-gravity Einstein once imagined, then dismissed as his greatest blunder. Unlike matter or radiation, dark energy does not clump or fade. It's a steady presence, growing more dominant as the universe expands. Today, it makes up 68% of all the energy in the cosmos. Yet we know almost nothing about it. Here's a wonder. Dark energy might be the energy of empty space itself. Quantum physics whispers that even a vacuum bubbles with fleeting particles, a quantum froth. Could this seething nothingness hold the key? Perhaps. But when scientists calculate the energy of this vacuum, the numbers clash wildly. Theory predicts a value 10 to the 120th power times larger than what we observe. It's as if the universe left us a riddle written in vanishing ink. Or maybe dark energy is something stranger. Some theorize a fifth force, a cosmic field called quintessence, rippling through the void. Others imagine extra dimensions, hidden folds in reality, leaking gravity into our world. We do not know. And in that uncertainty, there's poetry. The universe refuses to be fully known, guarding its secrets behind veils of shadow. Let's linger in history for a moment. The tale of dark energy is one of human humility. For centuries, we believed we were the center of creation. Then Copernicus moved us to the outskirts. Hubble revealed galaxies fleeing into the distance. And in 1998, Saul Perlmutter, Brian Schmidt, and Adam Rees handed us a new lesson. The universe is not just expanding, it's hurrying. Their Nobel Prize-winning discovery upended cosmology. Yet decades later, dark energy remains a silhouette against the unknown. What does it mean to share a universe with a force so dominant yet so elusive? Does it unsettle you? Or does it stir a quiet awe? Imagine all we've built, pyramids, symphonies, telescopes, existing in a cosmos where 68% of its essence defies comprehension. It's a reminder we are tiny, yes, but also brave. To ask these questions is to gaze into the abyss and smile. Now let your mind drift. Picture the universe in its final act. If dark energy persists, galaxies will vanish over the cosmic horizon, their light too stretched to reach us. Stars will flicker out, and space will grow cold, vast and silent, a big freeze. Or perhaps dark energy will strengthen, tearing atoms apart in a big rip. These are not prophecies, but possibilities. The universe writes its own story, and we are but brief characters in its epic. Yet here's a thought to hold close. Every mystery is an invitation. Dark energy, like dark matter, reminds us that the universe is more imagination than fact. What might lie beyond our equations? Could there be realms where dark energy sculpts new laws, new forms of existence? Close your eyes. Can you almost feel the pull of that unknown? As our journey slows, let's rest in this truth. Dark energy is not a flaw in the cosmos, but a feature. It's the universe saying, there is more to discover, more to wonder, more to dream. For all our science, we are still children tracing constellations on a cave wall, awed by the firelight, unaware of the stars waiting beyond. Are there any parallel universe? Let's venture beyond the edges of the known, into a realm where reality itself splinters into infinite possibilities. Settle into your coziest stillness. Close your eyes and imagine standing at the threshold of a cosmic library, each book a universe, each page a different version of you. Our journey begins with a question that has haunted poets and physicists alike. Are there parallel universes? Picture a moonlit forest where every path branches into new directions. Now imagine the universe as that forest. For centuries, we believed there was only one path, one timeline, one reality. But what if every choice, every chance, every twist of fate spawns a new world? A cosmos where you turned left instead of right, where dinosaurs still roam, or where light moves slower than sound. This is the tantalizing whisper of parallel universes. Not just science fiction, but a frontier of science itself. Let's unravel this gently. Begin with the tiniest building blocks of reality. In the quantum realm, particles exist in a haze of probabilities. An electron is here and there, spinning up and down until observed. In 1957, physicist Hugh Everett proposed a radical idea. What if every quantum possibility isn't a choice, but a branching path? Imagine a tree with infinite limbs. Each decision, a particle's spin, an atom's decay, splits reality into new timelines. This is the many worlds interpretation, a multiverse where every outcome unfolds somewhere, like raindrops falling into endless oceans. But quantum realms are not the only door. Consider the universe's birth. During the Big Bang, space-time may have stretched unevenly, like dough rising in an oven. Some regions inflated faster, cooled differently, crystallizing into separate, bubble universes with unique laws of physics. In this cosmic inflation theory, our universe is just one bubble in a froth of infinity. And then there's string theory, a vision of reality woven from tiny vibrating strings. To make the math work, these strings hum in 10 or 11 dimensions. Most are curled up, hidden. But what if other universes float in these higher dimensions, mere millimeters away, yet forever beyond our touch? Here's a wonder. The idea of parallel worlds is ancient. Hindu texts speak of endless lokas, layered realms of existence. Plato imagined shadows on a cave wall, hinting at truer realities beyond. Even Nietzsche mused about eternal recurrence, time looping infinitely, replaying every joy and sorrow. Modern science, it seems, echoes age-old dreams. In 2014, astronomers discovered a cold spot in the cosmic microwave background, the afterglow of the Big Bang. Some whisper it could be a bruise, a collision with another universe. The evidence is thin, like mist at dawn, but it ignites the imagination. What if our universe is nudging others in the dark, like ships passing in an unfathomable sea? Let's pause and wander through the implications. If parallel universes exist, somewhere there's an Earth where the Roman Empire never fell, where Mozart wrote symphonies for holograms, where you chose a different career, a different love, a different life. But here's the catch. These worlds are not mere mirrors. They might have different gravity, different colors, even different time. In some, matter is unstable, flickering out in seconds. In others, black holes bloom like flowers. Does this comfort you or unsettle you? There's solace in knowing every regret might be redeemed elsewhere, every road not taken still winding under alien stars. Yet there's melancholy too. How small we are, how singular, in a mosaic of infinities. Now let your mind drift deeper. Consider the anthropic principle. Our universe's laws seem finely tuned for life. If gravity were slightly stronger, stars would blaze out in moments. If weaker, no stars would form at all. But in a multiverse, every possible law exists. We simply inhabit the rare universe where conditions allowed us to ponder it. You, listening now, are the product of cosmic luck, a lottery winner in a sea of silent, lifeless worlds. What does that mean for purpose, for meaning? Perhaps it's a reminder that existence itself is a wild, improbable gift. Or maybe it's an invitation to live fully in this universe, even as others spin unseen. As our journey slows, let's rest in the mystery. Parallel universes may never be proven. They linger in equations, in the margins of data, in the human hunger for more. Yet isn't that the beauty of the unknown? It asks us to hold two truths at once, to cherish the world we know while daring to dream of others. Close your eyes once more. Picture the cosmic library, infinite and humming. Each book a story, each story a universe. And somewhere in that labyrinth, another version of you is also listening, also wondering, also breathing in the stardust of curiosity. What happened before Big Bang? Let's wander to the very limits of time and imagination. Picture a vast, silent canvas, one where even the concept of before has yet to be invented. Let your curiosity float, weightless, as we explore a question that has echoed through the ages. What happened before the Big Bang? Imagine the universe as a grand symphony. We know its notes, the birth of stars, the dance of galaxies, the rhythm of expanding space. But every symphony has an overture, a moment before the first note rings out. The Big Bang is often called the beginning, but what lies behind the curtain? A void? A previous universe? Or something beyond our language to describe? For thousands of years, humans have told stories of creation, gods shaping chaos into order, serpents coiled in primordial waters. Science offers its own epic, but it too reaches a threshold where time stumbles and answers dissolve into stardust. Let's begin with time itself. In our everyday lives, time flows like a river, past, present, future. But Einstein revealed that time is a thread woven into the fabric of space-time, bending around mass and energy. The Big Bang didn't just ignite matter and light, it created time. So asking what came before is like asking what lies beyond the edge of a map. The question itself trembles, unmoored. Yet science dares to dream beyond the horizon. One theory imagines a quantum vacuum, a realm of pure potential where universes bubble into existence like droplets in a boiling sea. Our cosmos might be one of countless others, each born from fluctuations in an eternal, unfathomable void. Another idea is the Big Bounce. Picture the universe as a phoenix. It expands, contracts in a fiery collapse, and then expands again, a cycle without beginning or end. Ancient cultures, from the Hindus to the Maya, envisioned cosmic cycles of creation and destruction. Modern equations suggest that if the universe's density were just right, a prior cosmos could have collapsed, rebounding as our Big Bang. Then there's the holographic principle. What if our three-dimensional reality is a projection, like a hologram, encoded on a two-dimensional surface at the universe's edge? In this view, the Big Bang might be the moment the projector flickered on, but the film reel could stretch back infinitely, frames of time we cannot see. Here's a wonder. Stephen Hawking proposed that time near the Big Bang becomes imaginary, a mathematical trick to smooth the singularity into something softer. Imagine the North Pole. All lines of longitude converge there, but there's no north of the North Pole. Similarly, Hawking's no-boundary model suggests the universe has no edge in time, no sharp beginning. It simply is, like a sphere with no starting point. Yet the human heart yearns for stories. How can something emerge from nothing? The philosopher Parmenides argued that nothingness cannot exist, there is only what is. Modern quantum physics oddly agrees. Even in a vacuum, particles flicker in and out of existence. Perhaps our universe is one such flicker, a rare but inevitable spark in an infinite sea of nothing. Let's drift through history. In 1927, a Belgian priest and physicist named Georges Lemaitre first proposed the primeval atom, a theory later called the Big Bang. Many scientists resisted, preferring a steady, eternal universe. But in 1965, the discovery of cosmic microwave background radiation, the afterglow of the Bang, turned skepticism into awe. Yet the question lingered: what sparked the spark? In the 1980s, physicist Alan Guth theorized cosmic inflation, a moment when the universe expanded faster than light itself, smoothing wrinkles in space-time. But what triggered inflation? Some say it was the death throes of a previous universe. Others imagine a quantum seed, a tiny fluctuation that blossomed into everything we know. Now let your mind wander further. Picture a realm without time, without space, not darkness, but a canvas without color or form. Then a shiver, a ripple in the void. A singularity forms, not as a point of matter, but as a knot of pure energy. It swells, ruptures, and unfolds into dimensions, up-down, left-right, past-future. From this, particles coalesce, stars ignite, and galaxies spiral into being. Can you feel the strangeness? The atoms in your hands, the air in your lungs, all were once part of that primordial fire. You are the universe, contemplating its own origins. As we near the end of our journey, let's rest in the mystery. The Big Bang may not be a beginning, but a doorway, a threshold our science cannot yet cross. The Tao Te Ching teaches, the way that can be spoken is not the eternal way. Science, in its humility, echoes this. Some truths are not facts, but horizons. What if the answer isn't a moment in time, but a transformation of what time is? What if before? Why does time only move forward? Meander through the quiet river of time. Settle into your softest stillness. Imagine standing at the edge of a stream, watching leaves drift endlessly forward, never circling back. Time, like that stream, flows in one direction. But why? Why can we remember yesterday, yet not glimpse tomorrow? Let's explore this mystery together. Time is the fabric of our lives. We measure it in heartbeats, seasons, and starlight. Yet it carries us in one unshakable direction: forward. A spilled glass of milk never gathers itself back into the cup. A candle melts but never reforms. Even the universe itself expands, never contracting. This is the arrow of time, a puzzle wrapped in the ordinary, pointing always toward the future. To understand this, we must wander into the realm of entropy. Imagine a child's room, toys scattered in chaos. Entropy is a measure of that disorder. The second law of thermodynamics whispers a simple truth. In a closed system, entropy always increases. The room grows messier, not tidier, unless energy is spent to clean it. This is why ice melts in sunlight, why perfume disperses in a room, why we age. The universe, too, is sliding from order to disorder, a process as inevitable as dawn. But here's the twist. The laws of physics are time-symmetric. Equations for gravity or quantum mechanics work just as well if time runs backward. So why don't we see shattered teacups leap back into our hands? The answer lies in the ancient past, in the moment the universe began. Picture the Big Bang, a hot, dense, unimaginably ordered state, a cosmic seed holding all the energy and matter of existence. As the universe expanded, it cooled, and entropy began its slow climb. We're still riding that wave, drifting from order to chaos. The arrow of time, then, is etched into the universe's very first breath. But what if the Big Bang was not a beginning, but a turn in the road? Some theorists imagine a mirror universe where time flows backward from the bang, a realm where light retreats into stars and people grow younger. Yet in our reality, entropy's rise locks time into a single direction. We are carried by the current, unable to paddle upstream. Let's linger in history. In the 19th century, physicist Ludwig Boltzmann grappled with entropy's paradox. He proposed that entropy is statistical, a matter of probability. There are more ways for a system to be disordered than ordered, so nature tends toward chaos. Imagine shuffling a deck of cards. An ordered sequence is rare, but random arrangements are countless. Time's arrow, then, is the universe shuffling itself into ever more probable states. Yet Boltzmann's ideas sparked debate. If entropy dictates time's flow, could a corner of the universe, by sheer chance, defy the trend? Could time reverse there? Theoretically, yes. But the odds are astronomically small. We'd need to wait longer than the universe's lifespan to see a cup unshatter. For all practical purposes, time marches forward. Now let's wander through philosophy. Ancient cultures saw time as cyclical, a wheel of seasons, births, and deaths. The Mayans, Hindus, and Greeks imagined eternal returns, worlds reborn in fire or flood. But modern science paints time as linear, a thread stretching from the Big Bang to an uncertain future. Which is truer? Perhaps both. The universe's arrow points forward, yet our lives echo rhythms, heartbeats, tides, orbiting planets that feel like cycles within the flow. And what of our minds? We perceive time as a river because our memories anchor us to the past, while the future remains a blank page. But imagine a being without memory. Would time lose its direction? Or a consciousness that experiences all moments at once? Such questions blur the line between physics and philosophy, between the measurable and the mystical. As we near the journey's end, let's ponder a cosmic wonder. Black holes, those devourers of light, may hold the ultimate fate of entropy. As they consume matter, they increase the universe's disorder. Some theorize that in the far future, when stars burn out and black holes evaporate, entropy will reach its peak. Time's arrow may falter then, in a cold, dark universe where change ceases. But that is a story for another era. For now, we live in a world where time flows forward, a gift wrapped in mystery. Every sunset, every falling leaf, every heartbeat is a testament to entropy's gentle tug. Can you feel it? The universe, whispering that all things must unravel, yet in that unraveling, create beauty. What is at the center of a black hole? Let's drift toward one of the universe's most enigmatic wonders. Settle into your quietest self. Imagine floating toward a darkness so profound it bends light itself, a place where the laws of physics falter and time slows to a whisper. Our journey tonight asks a question that has puzzled scientists and dreamers alike. What is at the center of a black hole? Black holes are cosmic paradoxes, regions of space-time where gravity grows so strong that not even light can escape. They are invisible, yet their presence warps the stars around them. They are silent, yet they devour galaxies. But what lies at their heart? A gateway to another dimension? A knot of infinite density? Or something beyond our wildest imagination? The story begins with a star's death. When a massive star exhausts its fuel, it collapses under its own weight, crushing matter into a point smaller than an atom. This is the birth of a singularity, a place where gravity becomes infinite and space-time curves into a bottomless well. Around it lies the event horizon, a boundary beyond which nothing returns. But the true mystery lies deeper, in the singularity's shadow. Let's unravel this gently. Einstein's theory of general relativity predicts that the heart of a black hole is a singularity, a point where matter is infinitely dense and space-time infinitely curved. Imagine crumpling a mountain into a grain of sand, then shrinking that grain smaller and smaller forever. Here, the mathematics of relativity break down. Equations explode into infinities, and science surrenders to the unknown. Yet nature abhors infinity. Physicists whisper of quantum gravity, a theory marrying Einstein's relativity with quantum mechanics, which might smooth the singularity into something stranger. Perhaps a fuzzy quantum foam, where space and time churn like storm clouds. Or a Planck star, a dense remnant rebounding from collapse hidden behind the event horizon. We do not know. The center of a black hole remains a riddle, veiled by the universe itself. Here's a wonder. Black holes might not have centers at all. In some theories, the singularity is not a point, but a ring, a portal to other universes. Picture falling through this ring like Alice tumbling down the rabbit hole, emerging in a cosmos where time flows backward or gravity repels. These are mathematical possibilities, but ones that stretch the fabric of imagination. Historically, the idea of a dark star dates back to the 18th century. Jean-Michel and Pierre-Simon Laplace imagined stars so massive their light could not escape. But it was Carl Schwarzschild in 1916 who solved Einstein's equations and revealed the mathematics of black holes. His work laid the groundwork for Stephen Hawking, who later discovered that black holes glow faintly, a whisper of quantum particles now called Hawking radiation. Let's pause and reflect. If you fell into a black hole, time would stretch like taffy. To an outside observer, you'd freeze at the event horizon, forever falling. But for you, the journey would continue, a descent into darkness pulled toward the singularity. Spaghettification would stretch your body into a thread, atom by atom. Yet even then, the singularity would remain elusive, a paradox cloaked in relativity's equations. Does this unsettle you, or does it stir awe? There's poetry in the idea that the universe holds places where human knowledge ends. The center of a black hole is not just a scientific question, but a mirror reflecting our limits. What might we learn if we could peek beyond the veil? Now, let your mind wander through the possibilities. Some theorists propose that singularities birth new universes, each with its own laws of physics. Others suggest that black holes are holograms, their interiors encoded on their surfaces, a cosmic illusion. And then there's the haunting idea that black holes are prisons, trapping information forever in a paradox that challenges quantum theory. Yet every mystery invites curiosity. In 2019, the Event Horizon Telescope captured the first image of a black hole's shadow, a halo of light around the abyss. It was a glimpse of the unseeable, a silhouette of infinity. But the heart of darkness remains untouched, a secret kept by the cosmos. As our journey slows, let's rest in the unknown. The center of a black hole may forever elude us, a reminder that some questions exist to humble, not to answer. In ancient myths, the void was a place of creation and chaos. Modern science, in its own way, agrees. What if the singularity is not an end, but a beginning? A stitch in the fabric of reality, weaving new threads of space-time? Or perhaps it's a cosmic cocoon, hiding truths we are not yet ready to grasp. How did life first begin on Earth? Let's journey back through the veils of time to an era when Earth was young, a world of fire and water, storm and silence. Settle into the stillness around you. Imagine a planet newborn, its seas simmering beneath alien skies. Our question tonight is as ancient as life itself. How did life first begin on Earth? 4 billion years ago, Earth was a molten canvas. Volcanoes spewed ash into a thin, toxic atmosphere. Lightning crackled over oceans that boiled and cooled with the tides. Yet within this chaos, something extraordinary happened. Non-living molecules began to dance, to replicate, to live. This transition from chemistry to biology is perhaps the universe's greatest magic trick. But how? For millennia, humans told stories of gods breathing life into clay or seeds of existence carried on comets. Science offers a different tale, one written not in myth, but in the language of elements and energy. Let's unravel it together. Our story begins with simple ingredients: water, methane, ammonia, and carbon dioxide. These molecules swirled in Earth's early oceans and atmosphere, stirred by volcanic heat and ultraviolet light. In the 1950s, chemists Stanley Miller and Harold Urey recreated these conditions in glass flasks. They zapped the mixture with electricity, mimicking primordial lightning. Within days, the once clear liquid turned pink, a broth of amino acids, the building blocks of proteins. Life's alphabet had been written. But letters alone do not make a story. The next step was assembly. Hydrothermal vents, cracks in the ocean floor where superheated water met minerals, may have been life's first workshop. Here, porous rocks acted as natural laboratories, concentrating molecules and fostering bonds. Fatty acids formed membranes. RNA, a cousin of DNA, emerged as a self-replicating molecule. These were not yet life, but they're whispers. Here's a wonder. Deep in the Australian outback, scientists found stromatolites, layered rocks built by microbes 3.5 billion years ago. These ancient organisms, simpler than any cell today, thrived in sunlit shallows, painting the world with oxygen. But their ancestors were born in darkness, in a time before photosynthesis. How did they cross the threshold from chemistry to life? Some say it began with a spark, a moment when molecules enclosed themselves in membranes, creating a boundary between self and world. These protocells could absorb nutrients, grow, and divide. Imperfect copies led to variation, then evolution. A molecular waltz became a symphony. Let's wander through history. Aristotle believed life arose spontaneously from mud or dew. Centuries later, Louis Pasteur proved that life comes only from life, yet he couldn't explain the first life. In 1871, Charles Darwin imagined a warm little pond where chemistry birthed biology. Today, we know that pond was likely a vent, a tide pool, or a comet's icy gift. In 1969, the Murchison meteorite fell to Earth, carrying amino acids forged in space. This hinted that life's ingredients are cosmic, scattered across galaxies. Perhaps life on Earth began with stardust, a gift from the heavens. Now let your mind drift. Picture a tide pool under a dim young sun. Waves lap at rocks slick with organic scum. Bubbles rise from the depths, each a tiny universe of possibility. Inside one bubble, a strand of RNA folds and copies itself. It's not alive, not yet, but it's dancing on the edge. What transformed that dance into life? Energy, perhaps? Lightning, geothermal heat, or the gentle gradient of a hydrothermal vent? Time, millions of years of trial and error. And chance, vast and patient, weaving simplicity into complexity. As our journey slows, let's rest in the mystery. Life's origin is not a single event, but a process, a slow awakening. The first cells were not born in a flash, but emerged like dawn, gradual and inevitable. Yet here's a thought to carry into dreams. Every atom in your body was once part of those ancient seas and stars. You are the universe, alive and wondering. The same forces that sculpted galaxies course through your veins. Are we alone in the universe? Let's gaze upward, beyond the shimmering veil of stars, into the infinite expanse where countless worlds spin in silence. Settle into your quietest self. Imagine the cosmos as a vast, uncharted ocean, each wave a planet, each ripple a possibility. Our question tonight is one humanity has carried for millennia. Are we alone in the universe? The night sky has always been a mirror. Ancient civilizations saw gods and heroes in the constellations. Sailors navigated by the stars, poets spun myths of celestial beings, and philosophers wondered if other minds gazed back. Today, we know the universe holds billions of galaxies, each with billions of stars, many circled by planets. The numbers whisper, Earth cannot be unique, yet the silence is deafening. Where is everyone? This is the Fermi paradox, the haunting gap between probability and proof. If life is likely, why have we found no signals, no artifacts, no cosmic neighbors? The answer, like the universe itself, may be written in shadows. Let's begin with the ingredients of life. Carbon, hydrogen, oxygen, the elements of stardust, are scattered across the cosmos. Water flows on Mars's ancient plains, swims in the icy oceans of Europa, and falls as methane rain on Titan. Amino acids, life's building blocks, have been found in asteroids and deep space clouds. The recipe for life seems universal. In 1953, chemists Miller and Urey zapped a primordial soup with electricity, creating amino acids. Their experiment suggested life's raw materials form easily. But life itself? On Earth, it arose swiftly. Within 500 million years of the planet's birth, single-celled organisms thrived. If life emerges wherever conditions allow, the galaxy should hum with vitality. Yet here we are, listening. In 1974, humanity sent its first deliberate shout into the void. The Arecibo message, beamed toward a star cluster 25,000 light-years away, encoded our DNA, our shape, our location. Decades later, we've heard no reply. But space is vast. That message has traveled only a fraction of the Milky Way's breadth. Imagine a letter adrift in an ocean. How long until it finds a shore? Meanwhile, telescopes like Kepler have discovered over 5,000 exoplanets. Some orbit in the Goldilocks zone, where temperatures allow liquid water, a cradle for life. One, named Kepler 452b, is called Earth's cousin, a rocky world circling a sun-like star. Does its sky hold clouds, rivers, cities? We may never know. The closest exoplanet, Proxima Centauri b, is 4 light-years away, a lifetime's journey with today's technology. Here's a wonder. In 1977, a radio telescope in Ohio detected the WOW signal, a burst of energy 30 times stronger than background noise. It lasted 72 seconds, matched the frequency of hydrogen, and has never been explained. Was it a cosmic hello, or just a passing comet sigh? The mystery lingers. Ancient cultures would have called such signals divine. The Dogon people of Mali spoke of Nomo, amphibious beings from Sirius. Hindu texts describe Vimanas, celestial chariots. Today, SETI scans the skies, not for gods, but for technosignatures, radio waves, laser pulses, Dyson spheres. But what if life elsewhere isn't technological? What if it's microbial or so alien we wouldn't recognize it? Let's wander through time. In 1610, Galileo's telescope revealed Jupiter's moons, proving Earth wasn't the center of all things. Centuries later, the Viking landers tested Martian soil for life, results debated to this day. The rovers Perseverance and Curiosity now seek fossils in ancient lake beds. But life, if it exists there, may hide underground, in briny seeps, or deep within ice. Consider extremophiles, Earth's hardiest life forms. They thrive in boiling vents, Antarctic ice, and nuclear reactor cores. If life can flourish here in such extremes, why not on Enceladus, where geysers spew water into space? Or on Venus, where microbes might float in sulfuric clouds? The universe, it seems, is patient. Life may be a spark waiting for the faintest breath of chance. Now let your mind drift. Picture a planet where forests glow in ultraviolet, where creatures communicate through magnetic pulses, where oceans ripple under 3 moons. Civilizations there might ponder the same question. Are they alone? Their scientists, too, might scan the skies, longing for connection. Or perhaps life is rare. Earth's story, a stable star, a protective moon, a magnetic shield, might be a cosmic lottery. Even then, in 1 trillion galaxies, 1 trillion Earths could exist. But space is so vast, time so deep, that civilizations might rise and fall like waves, never overlapping. Does this loneliness comfort you? Or does it stir a quiet ache? The universe is old, 13.8 billion years. If intelligent life is common, where are the ruins, the probes, the echoes? Some say advanced civilizations self-destruct. Others believe they outia. Why do we sleep and dream? Let's drift into the quiet mystery that visits us each day, a realm where time softens, the body rests, and the mind wanders through landscapes of shadow and light. Imagine the gentle pull of a tide drawing you into the depths of a question as old as consciousness itself. Why do we sleep and dream? Every creature on earth, from the humblest fruit fly to the loftiest giraffe, surrenders to sleep. Even trees and algae follow rhythms of rest. For humans, sleep is a paradox, a third of life spent in darkness, yet essential to everything we are. Dreams, meanwhile, are the mind's secret theater, stories written in riddles, starring fragments of our fears, desires, and memories. What is this nightly ritual? A biological necessity? A journey of the soul? Or a dialogue with the hidden self? Let's begin with the body. Each night, as light fades, your brain releases a whisper of melatonin, a hormone that lowers the curtains on wakefulness. Your core temperature drops, your breath slows, and neurons begin to pulse in unison, like fireflies signaling in the dark. This is the first stage of sleep, a shallow pool where you might twitch or feel yourself falling. Then, deeper waters. Your brain waves swell into slow, rolling waves, carrying you into non-REM sleep. Here, the body repairs itself, muscles knit, tissues regenerate, hormones like growth hormone surge. Your brain, too, begins its housekeeping. Glial cells flush away toxins that accumulated during the day, like beta amyloid, a protein linked to Alzheimer's. Sleep is the mind's custodian, sweeping the halls of memory. But the most mysterious phase is REM sleep, the realm of dreams. Your eyes dart beneath closed lids, your body lies paralyzed, and your brain blazes with activity, nearly as vivid as waking life. This is where stories unfold, surreal, emotional, often forgotten by dawn. Why do we dream? Ancient cultures saw dreams as messages from gods or glimpses of the future. The Egyptians built temples for dream incubation. Aristotle called dreams reflections of the day's residue. Freud believed they were windows to unconscious desires. Modern science offers softer truths. Some say dreams help process emotions, weaving raw feelings into memory. Others propose they're a playground for the mind, testing scenarios without real-world stakes. Consider the octopus which changes color as it dreams, replaying hunts in its sleep. Or rats, whose brains replay maze routes during REM, as if practicing. Humans, too, might rehearse social interactions or creative problems. A study found that people who dream of a maze navigate it faster in waking life. Dreams, it seems, are both archivists and innovators. Here's a wonder. Infants spend half their sleep in REM, while adults linger there just 20%. Is the developing brain building its world, brick by dreamlike brick? And in the 1960s, a teenager named Randy Gardner stayed awake for 11 days. By day 3, he hallucinated. By day 10, his speech slurred, his focus shattered. Sleep, we learned, isn't optional. It's the price of consciousness. Yet some creatures defy the rules. Dolphins sleep with one hemisphere of their brain at a time, remaining ever alert. Albatrosses nap while gliding over oceans. And the bullfrog, it's said, never sleeps, though who can say what dreams visit a frog? Now, let your mind wander. Have you ever woken with a solution to a problem as if your dreams had whispered the answer? Dmitri Mendeleev envisioned the periodic table in a dream. Mary Shelley dreamed the premise of Frankenstein. Paul McCartney heard the melody of yesterday in his sleep. Are dreams collaborators then? Silent partners in creativity? Or consider the paradox of nightmares. Why would the mind torment itself? Some psychologists believe nightmares are drills for survival, preparing us for threats. Others see them as unresolved emotions demanding attention. Even fear, it seems, has a purpose in the dark. As our journey slows, let's rest in the unknown. Sleep is both universal and deeply intimate. It's a biological act, yet it carries the weight of myth. We surrender to it nightly, trusting it to mend us, though we know so little of its inner workings. Perhaps sleep is a bridge between the body and the mind, the individual and the infinite. When we sleep, we return to a state older than thought, older than language. We are, for a time, as primal as the sea. How does consciousness arise? Let's drift into the most intimate of mysteries, one that breathes behind your eyes, coloring your world with sound, scent, and sensation. Imagine the soft glow of a lantern in the mind's deepest chamber. Our question tonight is both simple and infinitely profound. How does consciousness arise? Consciousness is the invisible thread stitching together your reality. It is the taste of rain, the ache of love, the memory of a childhood home. Yet for all its vividness, it eludes definition. How can 3 pounds of gelatinous tissue, the human brain, generate the symphony of selfhood? Philosophers have debated this for millennia. Scientists map neurons and neurotransmitters, yet the essence of consciousness remains a riddle, glowing softly in the dark. Let's begin with the brain itself, a universe of 86 billion neurons, each branching into thousands of connections. Electrical impulses dance along these pathways, weaving a tapestry of thought, perception, and emotion. But how does this biological machinery transform into experience? Why does the smell of rain feel nostalgic, or the color blue seem serene? Some theories whisper of integration. The integrated information theory proposes that consciousness emerges when brain regions communicate in a unified, complex way, like an orchestra playing a symphony rather than individual notes. The more interconnected the neurons, the richer the conscious experience. Another idea, the global workspace theory, imagines consciousness as a spotlight, illuminating certain thoughts for the mind's audience of memory and decision-making. Yet neither theory fully explains the leap from electricity to emotion. Here's a wonder. In the 1990s, scientists discovered neurons that fire not just when we perform an action, but when we watch someone else perform it. These mirror neurons hint that consciousness is, in part, a shared experience, a bridge between self and other. But even this revelation only skims the surface. Ancient cultures saw consciousness as a gift from the gods. The Egyptians believed the heart, not the brain, housed the soul. Aristotle called the mind the soul's first actuality. Descartes split reality into body and spirit, a duality science now challenges. Today, we know even simple creatures, bees, octopuses, mice, exhibit sparks of awareness. Consciousness, it seems, is a spectrum, not an on-off switch. Let's wander deeper. Consider the hard problem of consciousness, a term coined by philosopher David Chalmers. It asks why physical processes in the brain feel like anything from the inside. Why isn't the brain a silent, dark machine? Some suggest consciousness is fundamental, like space or time, a property woven into the universe's fabric. Others argue it's an illusion, a story the brain tells itself to make sense of chaos. In the East, Hindu and Buddhist traditions have long pondered consciousness. The Upanishads describe Atman, the true self beyond thought. Buddhism speaks of anatta, the illusion of a permanent self. These ancient insights eerily echo modern neuroscience, which finds no central controller in the brain, only a chorus of competing voices. Now let your mind linger on this. Patients under anesthesia lose consciousness despite active brains. Comatose individuals sometimes later recall conversations, hinting at hidden layers of awareness. And in near-death experiences, people describe vivid visions, tunnels of light, departed loved ones, suggesting consciousness might persist, however briefly, beyond the brain's shutdown. What does this mean? Is the brain a receiver, tuning into consciousness like a radio to waves? Or is it the sole creator? The questions multiply. Could a machine ever be conscious? AI systems like chatbots mimic human thought, but do they feel? Philosopher Thomas Nagel once wrote, "There is something it is like to be a bat, but there is nothing it is like to be a computer. No inner world, no joy or longing." Consciousness remains biology's exclusive art. As our journey slows, let's rest in the mystery. Consciousness may be the universe's way of knowing itself, a spark ignited in the dark, longing to understand its own light. Every laugh, every tear, every moment of awe is a note in this cosmic song. We may never fully unravel how consciousness arises, but perhaps the search itself is a kind of awakening, an invitation to marvel at the fact that we can wonder, fear, and love it all. You, listening now, are the universe contemplating its own existence. What greater magic is there? Why do we yawn? Let's explore a quiet, familiar mystery, one that begins with a deep breath, a stretch of the jaw, and a sigh that seems to echo through the ages. Settle into your softest stillness, close your eyes, breathe gently, and let your mind wander to a question as simple as it is profound. Why do we yawn? Yawning is a silent symphony shared by all. Humans yawn, so do dogs, cats, birds, even fish. It begins in the womb, a tiny stretch of life not yet born. Yet despite its universality, yawning remains wrapped in enigma. Is it fatigue, boredom, or something deeper, written into the code of our biology? For centuries, yawning was dismissed as a mere reflex. Hippocrates thought it expelled bad air from the lungs. Others believed it balanced the body's humors. Today, science offers clues, but the full story still drifts just out of reach. Let's unravel this gently. A yawn begins with a slow inhale, mouth wide, chest rising. The jaw stretches, the eardrums tighten, and for a moment, the heart quickens. Then, the exhale, a release, a softening. This dance lasts about 6 seconds, yet its purpose is debated. One theory whispers of cooling the brain. When we yawn, fresh air rushes into the sinus cavities, chilling blood flowing to the brain. Studies show people yawn more in warm weather, and pressing a cold pack to the forehead reduces yawning. Like a computer fan, the brain may use yawns to regulate its temperature, ensuring clarity in the hum of thought. Another idea speaks of oxygen. But experiments reveal yawning doesn't spike oxygen levels. Instead, it might redistribute surfactants in the lungs, keeping them supple, or reset the rhythm of breathing, like a metronome tuning the body's cadence. Here's a wonder: yawning is contagious. Reading this, you might feel the urge to yawn. Even thinking about yawning can trigger it. This mimicry is rooted in empathy. Brain scans show contagious yawning activates regions linked to social bonding, the same areas that light up when we read emotions. The more empathetic you are, the more likely you'll catch a yawn. But why? In our distant past, synchronized yawning might have signaled group rest or alertness. Wolves yawn before hunts, penguins yawn during courtship, and chimpanzees yawn contagiously, strengthening social ties. A yawn, then, could be a silent language, a ripple of connection passed through time. Let's wander through history. Ancient Greek physicians prescribed yawning to relieve vapors of the soul. In 17th century Europe, excessive yawning was thought to invite demonic possession. Even today, superstitions linger, covering one's mouth to trap the escaping soul. Science, too, has danced with the mystery. In the 1980s, researchers noticed fetal yawning in the womb, long before breathing begins. These yawns might shape the developing jaw or stimulate brain growth, a rehearsal for life's first breath. And then there's the paradox. We yawn when tired, but also when waking. Before moments of stress, athletes yawn before races, musicians before performances. Is it the body's way of gathering strength, like a bowstring pulled taut before release? Now, let your mind drift. Picture a flock of birds rising at dawn, each stretching its beak in unison. Or a lioness yawning in the savanna grass, her cubs mirroring her in a chain of sleepy synchrony. What stories do their yawns tell? Perhaps yawning is a relic of our ancient past, a rhythm older than language. A reminder that we are animals, bound by biology, yet yearning to understand the rituals that pulse beneath our awareness. As our journey slows, let's rest in the simplicity of not knowing. Yawning may be a tool for cooling, a social signal, a breath of preparation, or all these things woven into a single, silent act. There's beauty in the mystery. Each yawn is a whisper from the body, a gentle nudge to pause, to breathe, to reconnect with the primal self. In a world that prizes answers, some questions exist to remind us of wonder. What is the true nature of gravity? Let's drift into the invisible embrace that binds the cosmos, a force so quiet, so patient, it sculpts galaxies and guides falling leaves alike. Imagine floating in the space between stars, where the universe's gentle hand rests upon all things. Our journey begins with a question that has tugged at human curiosity for centuries. What is the true nature of gravity? Gravity is the universe's silent architect. It pulls rain from clouds, roots trees to the earth, and spins planets into their celestial dances. Yet for all its familiarity, gravity remains deeply mysterious. It is not a force in the traditional sense, nor a push or pull we can see. It is a whisper woven into the fabric of reality itself, a curve in the stage on which all matter moves. Let's unravel this gently. In 1687, Isaac Newton sat beneath an apple tree, pondering the moon's path across the sky. When an apple fell, he glimpsed a truth. The same force pulling fruit to earth held the moon in orbit. He called it gravity, a mathematical law, elegant and universal. For centuries this sufficed, but Newton admitted ignorance of gravity's essence. What caused it? The question lingered like stardust. In 1915, Albert Einstein reimagined gravity entirely. He proposed that massive objects like stars and planets warp the fabric of space-time, a four-dimensional tapestry of space and time. Imagine placing a heavy stone on a stretched sheet. The fabric curves and marbles nearby roll toward it. Gravity, Einstein said, is not a force but the shape of space-time itself. Objects follow these curves like leaves caught in a river's current. Here's a wonder. Einstein's theory predicted black holes, regions where space-time curves so intensely that not even light escapes. It also foresaw gravitational waves, ripples in space-time caused by cataclysmic events like colliding neutron stars. In 2015, scientists detected these waves, confirming Einstein's vision a century later. Gravity, it seems, is the universe's storyteller, etching its tales into the void. Yet mysteries remain. Gravity is the weakest of nature's forces, a trillion times weaker than the force holding atoms together. Why? Some whisper of hidden dimensions, coiled too tightly to perceive, where gravity's strength dissipates. Others propose particles called gravitons, hypothetical messengers of gravitational attraction, though none have been found. Let's wander through time. Ancient Greeks believed objects fell toward Earth because it was the natural place of heavy things. Medieval scholars thought angels pushed the planets. Newton's equations tamed the cosmos into predictability, but Einstein's relativity revealed a deeper, stranger truth. Today, physicists seek a theory marrying gravity with quantum mechanics, a theory of everything. The quest has birthed ideas like string theory, where gravity arises from vibrating strands of energy, and loop quantum gravity, which pixels space-time into tiny, woven loops. But the heart of the mystery endures. Why does space-time curve? What breathes life into Einstein's equations? The answers may lie beyond our current grasp, in realms where time has no beginning and dimensions fold like origami. Now, let your mind drift. Picture Earth as a grand ballroom and gravity as the music guiding every dancer. Comets, oceans, your own heartbeat. Without gravity, stars would never ignite, planets would never form, and light would wander aimlessly. Yet this force, so essential, resists full understanding. Is it a property of matter, a structure of reality, or something else, waiting just beyond the edge of our equations? Consider this. Every time you drop a pen, you're witnessing a phenomenon that connects you to the birth of the universe. The same gravity that tugs that pen to the floor once pulled stardust into galaxies. You are, in this moment, dancing with the same force that shaped existence. As our journey slows, let's rest in the humility of not knowing. Gravity is both a law and a riddle, a reminder that the universe guards its deepest secrets closely. For all our science, we remain like Newton beneath his tree, awed by the fall of an apple, yet sensing infinities in its arc. Perhaps gravity's true nature is not a puzzle to solve, but a mirror reflecting our endless curiosity. It invites us to look deeper, to wonder wider, and to embrace the beauty of questions without answers. Why do we have left-handed and right-handed molecules? Let's wander into a hidden world, a realm where molecules mirror each other like cosmic twins, yet refuse to hold hands. Imagine a dance of tiny structures twisting left and right in perfect symmetry. Our journey begins with a question as delicate as a snowflake's design. Why do we have left-handed and right-handed molecules? In the quiet of a laboratory in 1848, Louis Pasteur peered through a microscope at crystals of tartaric acid. To his astonishment, he saw two distinct forms, mirror images, like left and right hands. These molecules were identical in composition, yet their shapes could not be superimposed. Pasteur called this property chirality, from the Greek word for hand. Life, he realized, has a curious preference. Amino acids, the building blocks of proteins, are almost all left-handed, while the sugars in DNA spiral rightward. Why does nature favor one hand over the other? Let's unravel this gently. Imagine a staircase that twists only clockwise, or a key that fits a lock in just one orientation. Chirality shapes life's architecture. Molecules, like hands, come in pairs, mirror reflections that cannot be flipped to match. This is not mere geometry. The twist of a molecule determines how it interacts with the world. A left-handed drug might heal, while its right-handed twin could poison. Life, it seems, chose sides long ago. But why? In the primordial soup of early Earth, both forms should have arisen equally. Yet when scientists analyze meteorites or simulate prebiotic chemistry, they find slight imbalances. Some force tipped the scales. Was it chance? Or something deeper? Here's a wonder. Sunlight may hold a clue. Light waves normally vibrate in all directions, but when polarized, filtered to a single plane, they can influence molecular handedness. In 1957, chemists proposed that polarized starlight, spiraling through magnetic fields in space, subtly favored one chiral form. Over eons, this bias seeded life's preference. Imagine a cosmic wind blowing leftward, nudging molecules into the shape of life. Or consider the weak nuclear force, the only fundamental force that distinguishes left from right. Though imperceptibly faint, it interacts differently with particles, creating a tiny preference in certain reactions. Could this microscopic bias ripple upward, shaping the molecules of life? Let's wander through history. In 1953, Stanley Miller and Harold Urey zapped a primordial soup with electricity, creating amino acids, but both left and right-handed forms. The mystery deepened. Then, in 1969, the Murchison meteorite crashed into Australia, carrying amino acids with a slight excess of left-handed ones. The universe, it seemed, had whispered a preference before life began. Yet the answer remains elusive. Some theorize that early life sampled both forms, but a single chiral choice allowed tighter molecular cooperation. Others imagine a frozen moment of chance, a coin toss frozen in time, locking biology into a leftward path. Now let your mind drift. Picture a planet where life chose right-handed amino acids. Would its creatures resemble us? Or would evolution spin entirely new forms? And what of alien life? Might it mirror our chemistry or dance to an opposite twist? There's poetry in this asymmetry. Chirality is a reminder that symmetry, so common in crystals and snowflakes, breaks in the realm of life. Perhaps imperfection is essential to existence, a flaw that allows complexity to bloom. As our journey slows, let's rest in the beauty of the unknown. Chirality is a silent architect, shaping everything from the helix of DNA to the scent of a lemon. Its origins may lie in starlight, in quantum forces, or in the randomness of ancient seas. But the deeper truth is this: life's preference for one hand over the other is a signature of our cosmic story, a choice etched into the molecules of being. How big is the universe? Let's embark on a journey to the farthest edges of imagination, a voyage through space so vast it humbles even the grandest of dreams. Picture yourself floating gently, untethered, as we contemplate a question that has echoed across millennia. How big is the universe? The universe is a tapestry woven with starlight and shadow. From our tiny blue planet, the night sky seems infinite, a scattering of diamonds on black velvet. But the truth is far stranger, far more magnificent. The cosmos stretches beyond comprehension, a realm where distance and time blur into a single, endless whisper. Let's begin close to home. Earth, a pale blue dot suspended in sunlight, orbits a star we call the Sun. To grasp the scale, imagine shrinking the solar system to a single city block. The Sun would glow at the center, no larger than a grapefruit. Earth, a peppercorn, orbits 25 meters away. Neptune, the outermost planet, circles at the edge of the neighborhood. Yet this is just our cosmic backyard. The nearest star, Proxima Centauri, lies 4 light-years distant. If that city block were the distance to the Moon, reaching Proxima would require a journey to Mars. Even at light speed, a blistering 300,000 kilometers per second, a probe would take 40,000 years to cross the gulf. Space, it seems, is mostly emptiness, a cathedral of nothingness. Now let's expand our gaze. Our Milky Way galaxy swirls with 100 billion stars, each a possible sun to other worlds. If the galaxy were a dinner plate, the solar system would be a grain of pollen near its edge. Yet the Milky Way is just one of 2 trillion galaxies in the observable universe, a term key to our story. The observable universe is a sphere centered on Earth, stretching 93 billion light-years in diameter. Why so large when the universe is only 13.8 billion years old? Because space itself is expanding. Distant galaxies flee from us faster than light can chase them, their light stretching into infrared whispers. We see not where they are, but where they were, ghosts of the cosmic dawn. Here's a wonder: the entire universe may be far grander. Beyond our observable horizon, space could stretch infinitely, filled with galaxies forever unseen. Or it might curve back on itself, like the surface of a balloon. We do not know. The cosmos guards its ultimate size like a secret. Ancient cultures sensed this vastness. The Greeks spoke of the aion, a timeless expanse. Hindu texts described universes nested within universes, each breath of Brahma lasting billions of years. Today, telescopes like Hubble and Webb show us galaxies so distant their light has traveled over 13 billion years to reach us, a snapshot of infancy in a now ancient cosmos. Let's pause to grasp the scale. If every star in the Milky Way were a grain of sand, all its stars would fill a child's wagon. The observable universe's stars would bury a mountain. Yet even this is but a fraction of what may exist. Some theories suggest the universe is a multiverse, a bubble in an endless froth of cosmic realms, each with different laws. But let's return to what we can see. The cosmic web, a labyrinth of galaxies, threads through the void in filaments and clusters. Between them lie voids, deserts of darkness spanning hundreds of millions of light years. In this tapestry, humanity is smaller than a quark, yet we map the abyss. Now let your mind wander. Picture a spacecraft traveling forever. Would it ever reach the universe's edge? Or would space stretch endlessly, galaxies receding like mirages? What lies beyond the expansion? A wall of nothing? A mirror? Or more universe, eternal and unknowable? Consider this. Every atom in your body was forged in the hearts of stars, scattered across space by supernovae, and gathered here, now, to ponder the cosmos. You are the universe contemplating itself, a fleeting thought in an endless mind. As our journey slows, let's rest in the mystery. The universe's size is not just a measure of space, but of human curiosity. Each time we peer deeper, we find new questions, new layers of wonder. Perhaps the cosmos expands not just outward, but inward, into realms of imagination and awe. What causes the placebo effect? Let's explore a quiet miracle hidden within us all, a phenomenon where belief becomes biology, and the mind heals the body with nothing but a whisper of hope. Imagine a world where sugar pills mend pain, saline injections ease despair, and the mere expectation of healing sparks transformation. Our journey begins with a question as old as medicine itself. What causes the placebo effect? The placebo effect is the ghost in the machine of modern science. Patients given fake pills, sham surgeries, or dummy treatments often improve, even when they know the remedy is inert. Pain fades, tremors still. Moods lift. How can belief alone rewrite the body's story? The answer lies in the alchemy of mind and matter, a dance of chemistry, expectation, and ancient survival instincts. Let's unravel this gently. When you believe a treatment will work, your brain releases a cascade of neurotransmitters. Endorphins, nature's painkillers, flood the bloodstream. Dopamine, the molecule of anticipation, sharpens focus and optimism. The immune system stirs, cytokines quiet inflammation, and the heart rate steadies. This is not imagination, it is physiology. The brain, convinced of healing, becomes a pharmacy. But how? Functional MRI scans reveal that placebos activate the same neural pathways as real drugs. A sugar pill labeled morphine lights up the brain's pain control regions. A fake inhaler opens airways in asthma patients. The mind-body bridge, once mystical, is now mapped in synapses and blood flow. Here's a wonder. The placebo effect grows stronger with ritual. A pill's color matters. Blue calms, red energizes. Injections work better than pills. Expensive placebos outperform cheap ones. Even a doctor's white coat or warm demeanor can amplify the cure. Healing, it seems, is theater. The brain craves symbols, stories, and care as much as chemistry. Ancient cultures understood this intuitively. Shamans chanted over herbs. Greek temples of Asclepius blended sleep therapy with divine visions. In the 18th century, doctors prescribed bread pills to pacify patients. Today, placebos remain medicine's shadow, a reminder that trust is as vital as technology. Let's wander through history. In World War II, nurse anesthesia ran out of morphine. Desperate, she injected wounded soldiers with saline, telling them it was pain relief. To her shock, many relaxed, their agony eased. This moment sparked modern placebo research. Later, in the 1970s, scientists discovered that blocking endorphins with a drug called naloxone also blocked placebo pain relief. The body's own opioids, it turned out, were the secret. But placebos do more than ease pain. Parkinson's patients given fake dopamine pills exhibit improved motor control. IBS sufferers report relief from sham acupuncture. Even the immune system bows to belief. Placebo vaccines can rally antibodies. The mind, it seems, holds a master key to the body's labyrinth. Now, let your mind drift. What if the placebo effect is not a trick, but a primal survival tool? Early humans who believed in healing herbs or rituals might have calmed stress responses, boosting immunity. Hope, in this light, is an evolutionary advantage, a way to marshal the body's resources when danger looms. But there's a darker twin, the nocebo effect. Fear of harm can manifest symptoms. Patients warned of a drug's side effects experience them more often, even when given placebos. Words like, "this might hurt," amplify pain. The mind's power to harm is as potent as its power to heal. As our journey slows, let's rest in the paradox. The placebo effect is both profound and fragile. It works best when wrapped in authority, empathy, and ritual, yet crumbles under skepticism. It challenges the divide between real and imagined, asking us to see the mind not as a passenger, but as a pilot. Perhaps the deepest lesson is this: healing is relational. A doctor's gaze, a caregiver's touch, the weight of a pill in the palm. All are threads in the tapestry of recovery. The placebo effect is not a lie, but a testament to the stories we tell ourselves about survival, hope, and connection. Why does lightning sometimes strike upwards? Let's wander into the electric heart of a storm, where the sky and earth trade secrets in flashes of light. Imagine standing at the edge of a tempest, a dance of shadows and brilliance. Our journey begins with a question that crackles with mystery. Why does lightning sometimes strike upwards? Lightning is often pictured as a jagged bolt hurling itself earthward, a celestial spear seeking the ground. But high above cities and mountains, a reverse phenomenon occurs. Towers, wind turbines, and skyscrapers send luminous tendrils upward, meeting the storm's fury halfway. This is upward lightning, a rare, mesmerizing dialogue between land and cloud. How does the earth itself reach out to the heavens? Let's unravel this gently. Within a storm cloud, ice crystals collide, scattering electrons like sparks from a grindstone. The cloud's base grows heavy with negative charge, while the ground below bristles with positive energy. Normally, a stepped leader snakes downward, branching like a root, until a surge of light, the return stroke, races back up. But sometimes, the script flips. Tall structures, spires of steel, monuments of human ambition, act as lightning rods for the sky's curiosity. As the cloud's charge intensifies, the electric field around these towers becomes a simmering cauldron. The air ionizes, molecules splitting into conductive plasma. From the tower's peak, a faint leader ascends, climbing eagerly toward the storm. When it meets the cloud's descending charge, the circuit closes. A luminous bridge ignites, earth to sky. Here's a wonder. Upward lightning often unfolds in slow motion. Unlike the instantaneous flash of cloud-to-ground strikes, these bolts crawl skyward at a leisurely pace, sometimes lasting a full second. They pulse with a ghostly blue-white glow, as if the earth itself is whispering to the clouds. The Empire State Building, struck over 20 times a year, becomes a conductor in this electric symphony, its spire crowned with St. Elmo's fire before the bolt ascends. Ancient cultures might have seen these upward strikes as divine threads. Norse myths told of Thor's hammer connecting Asgard to Midgard. Today, science reveals a truth just as poetic. Our tallest structures don't just attract lightning, they initiate it, bending the laws of physics to join the sky's dance. Now let your mind drift. Why do these upward bolts favor winter storms? Ice, it seems, is a silent collaborator. Frigid tempests churn with graupel, soft hail, that amplifies charge separation. Wind turbines in the North Sea, offshore oil rigs, and alpine observatories become stages for this inverted light show. Even rockets have triggered upward lightning, their trails of ionized gas drawing bolts like moths to flame. But there's a darker side. Upward lightning often carries a positive charge, a rare, supercharged bolt with 10 times the power of ordinary strikes. These giants can leap from cloud tops to the ionosphere, spanning dozens of miles. They remind us that electricity, like the universe itself, defies simple rules. As our journey slows, let's rest in the paradox. Upward lightning is both a human artifact and a force of raw nature. Our towers, built to scrape the sky, become portals for a primordial conversation. They remind us that even in our mastery of steel and wire, we are still partners in Earth's oldest rituals. Perhaps this phenomenon is a metaphor, a reminder that growth and reach inevitably attract both risk and wonder. To build upward is to flirt with the heavens, to invite the storm's electric kiss. Why do cats purr? Let's curl into the softest mystery of the animal kingdom, a sound that hums through quiet rooms, vibrating with warmth and wonder. Settle into stillness and imagine a cat nestled in your lap, its body a living instrument playing a melody older than time. Our journey begins with a question as comforting as it is enigmatic. Why do cats purr? Purring is the heartbeat of a cat's soul. It begins as a kitten's first language, a vibration felt more than heard, as blind newborns nuzzle their mother. But purring is not just a song of contentment. Cats purr when injured, frightened, or even dying. This gentle rumble, it seems, is a Swiss Army knife of sound, a tool for survival, healing, and connection. How does a creature so small hold such power in its throat? Let's unravel this gently. A cat's purr originates deep within its body. As the diaphragm contracts and the larynx muscles flutter up to 150 times per second, air vibrates through the vocal cords, creating that familiar hum. But unlike a human voice, purring requires no exhale. Cats can purr while breathing in and out, a continuous murmur that defies ordinary biology. Yet the true magic lies in purpose. A mother cat purrs to guide her kittens, born deaf and blind, to the safety of her milk. Kittens purr back, bonding in a duet of vibrations. But adult cats carry this habit into their twilight years. Why? Here's a wonder: purring may be a form of self-healing. Studies reveal that cat purrs vibrate at frequencies between 25 and 150 hertz, a range known to stimulate bone growth, repair tendons, and ease pain. These vibrations, like tiny massages, may help cats recover from injury, reduce swelling, and even maintain muscle tone during long hours of rest. Imagine a built-in therapy session humming beneath fur and flesh. Ancient Egyptians, who revered cats as divine beings, believed purring channeled the voice of Bastet, the goddess of home and protection. Modern science offers a different divinity: evolution. Wild cats may have evolved purring to stay healthy during prolonged stillness while hunting or hiding. The vibration became a survival tool, a way to mend quietly in the shadows. Now let your mind wander. Why do cats purr when stressed? A visit to the vet? A thunderstorm? The prick of a needle? Their bodies hum through fear. Some scientists think purring releases endorphins, nature's painkillers, soothing both body and mind. Others suggest it's a signal of trust, a way to say, "I am harmless," to predators and humans alike. But there's another layer. Cats often purr while grooming each other or kneading their paws, a throwback to kittenhood when kneading stimulated milk flow. The purr becomes a bridge between past and present, a lullaby for their inner child. Let's drift through history. In medieval Europe, cats were unjustly feared as familiars of witches. Yet even then, their purrs were prescribed as cures for ailments, earaches, insomnia, even melancholy of the spirit. Today, therapy cats visit hospitals, their purrs lowering human blood pressure and calming anxious hearts. The sound, it seems, transcends species. And what of bigger cats? Lions, leopards, and cheetahs cannot purr. They roar instead. Only the small cats, house cats, bobcats, lynxes, possess this gift. Their purr is a secret handshake, a trait that binds them to our hearths and hearts. As our journey slows, let's rest in the simplicity of not knowing. Purring remains a paradox, a sound of joy and pain, communication and solitude. It reminds us that even the most familiar creatures guard mysteries. A cat's purr is both a comfort and a question, a vibration that hums, "There is more to me than you see." Perhaps this is why we find it so soothing. In a world of noise, the purr is a meditation, a rhythm that invites us to slow down, to listen not just with our ears, but with our bones. How do migrating animals navigate so precisely? Let's drift into the silent ancient pathways of the natural world, a realm where creatures embark on journeys spanning continents and oceans, guided by forces unseen. Settle into stillness and imagine the flutter of a monarch's wings, the song of a humpback whale, or the steady pulse of a caribou herd. How do these travelers navigate with such precision, crossing thousands of miles without maps or compasses? Let's wander through the mystery together. Migration is one of Earth's oldest poems. Arctic terns fly from pole to pole, logging a lifetime distance equal to 3 trips to the moon. Sea turtles hatch on sandy beaches and return decades later to the same shore, as if pulled by invisible strings. Salmon thread through labyrinthine rivers, finding their birthplace through currents they've never known. These feats defy logic, yet they happen season after season, generation after generation. What whispers guide them? The answer lies in a symphony of senses, honed over millions of years. Let's begin with the Earth itself. Deep within our planet, molten iron swirls, generating a magnetic field that stretches into space. Many animals, birds, sea turtles, even butterflies, sense this field like an invisible map. In their bodies, tiny crystals of magnetite, a magnetic mineral, act as compass needles. When a robin tilts its head or a loggerhead turtle glides through the ocean, they're reading the planet's magnetic signature, tracing latitude and longitude written in magnetism. But magnetism is just one verse in the song. Celestial cues also guide the way. Birds like indigo buntings calibrate their routes by the stars, learning constellations as nestlings. On cloudy nights, they turn to the sun's polarized light, which paints patterns in the sky invisible to human eyes. Even the moon's glow helps beach-bound hatchlings scurry seaward, away from shadowy dunes. Here's a wonder. Some animals carry maps in their genes. Young cuckoos, raised by foster parents, migrate alone to ancestral wintering grounds they've never seen. Monarch butterflies, over several generations, complete a round trip from Canada to Mexico. How? Their DNA holds ancestral memories, coded instructions for when to turn, rest, or ride the wind. It's as if the journey itself is inherited, a story written in molecules. Humans once navigated by similar intuition. Polynesian voyagers read waves and stars. Vikings used sunstones to polarize light. But animals surpass us. Pigeons detect infrasound, rumblings from distant storms or mountains, to orient themselves. Salmon imprint on the unique chemical signature of their birth streams, a scent map carried in their cells. And dung beetles, of all creatures, navigate by the Milky Way, rolling their treasures in straight lines under starlit skies. Now, let your mind wander. How does a newborn albatross, alone on the open ocean, know to circle the earth on wings that have never tired? What ancient dialogue exists between a whale's song and the magnetic pulses of seamounts? Science offers clues, but the full truth remains veiled. Perhaps animals sense gradients we cannot, subtle shifts in air pressure, the angle of sunlight, or the Earth's electric fields. Or maybe they perceive time itself, their internal clocks synchronized with planetary rhythms. Consider the bar-tailed godwit, which flies non-stop from Alaska to New Zealand, 8 days without rest. Fatigued, half its body weight gone, it still descends onto the same muddy estuary each year. Does it feel the tug of memory? Or is it answering a call older than continents? As our journey slows, let's rest in the humility of wonder. Migration is not just movement, it's a dialogue between life and earth, a testament to resilience etched into bone and feather. These travelers remind us that the planet is alive with guidance, magnetic whispers, star maps, and scent trails woven into the wind. Perhaps deep within us echoes a fragment of this ancient wisdom. Have you ever felt an inexplicable pull toward a place or path? A quiet knowing, like a thread in the blood? Migration is the universe's way of reminding us that all life is journeying, guided by forces seen and unseen. What causes ball lightning? Let's drift into the heart of a storm, where the sky's fury births a mystery as fleeting as it is mesmerizing. Settle into stillness and imagine a world where lightning doesn't just strike, it dances. Glowing orbs, adrift on the wind, flickering like lanterns carried by unseen hands. Our journey begins with a question that has puzzled scientists and poets alike. What causes ball lightning? Ball lightning is a paradox, a whisper of light in the chaos of a storm. Witnesses describe it as a sphere, sometimes no larger than a grapefruit, hovering above the ground, drifting through walls or floating down chimneys. It glows with an unearthly light, white, blue, or even red, and vanishes as suddenly as it appears, often with a pop or a hiss. For centuries it was dismissed as myth, a trick of weary eyes. But its fleeting beauty is real, and its secrets linger in the shadows of science. Let's unravel this gently. Ordinary lightning is a bolt, a violent exchange of energy between clouds or between sky and earth. Ball lightning, however, is a riddle wrapped in that energy. One theory suggests it begins when a lightning strike vaporizes soil or metal, releasing tiny particles of silicon into the air. These particles, charged with electricity, oxidize and glow, forming a self-sustaining sphere. Like a candle flame feeding on wax, the ball consumes itself until it winks out. Another idea whispers of electromagnetic knots, twisted fields of energy left behind by lightning, trapping plasma in a shimmering bubble. Or perhaps microwaves generated by storms resonate in the air, ionizing gases into a brief, radiant orb. Yet no single theory fully explains the accounts. Balls that float through airplane cabins, glide over lakes, or vanish into thin air, leaving the scent of ozone. Here's a wonder. In 2014, Chinese scientists captured ball lightning on video and spectrograph. They observed a glowing sphere drifting for seconds, its spectrum rich with silicon, iron, and calcium, elements found in soil. This rare evidence supports the vaporized mineral theory, yet mysteries remain. Why do some balls last minutes, while others vanish in a breath? How do they defy gravity or pass through glass without shattering it? History brims with tales. Medieval sailors feared ball lightning as St. Elmo's fire. Elmo's fire, a portent of doom. In 1638, a glowing sphere tore through an English church, smashing pews and filling the air with sulfur. Tolstoy wrote of one floating into a room in War and Peace, terrifying guests. These stories, once dismissed as folklore, now hint at a phenomenon as old as thunderstorms themselves. Now let your mind wander. Imagine a stormy night, a crack of lightning, then silence. A sphere of light drifts into your room, humming softly. It hovers, alive with curiosity, before dissolving into shadows. What would you feel? Awe, fear, or the quiet sense that nature still holds cards close to its chest? Science thrives on such mysteries. Ball lightning reminds us that even in an age of satellites and quantum computers, the universe guards wonders that defy textbooks. It is a lesson in humility, a glowing testament to the unknown. As our journey slows, let's rest in the beauty of uncertainty. Ball lightning may be a knot of energy, a phantom of chemistry, or something beyond our current grasp. But its fleeting dance invites us to marvel, not just at the phenomenon, but at the human urge to seek answers. Perhaps some mysteries are not meant to be solved, but savored, like the brief glow of a firefly or the shadow of a question mark hanging in a stormlit sky. Why does the universe exist at all? Let's journey to the edge of wonder, to a question that has echoed through the ages, whispered by stars, pondered by philosophers, and carried in the silent spaces between heartbeats. Imagine the universe not as a vast expanse, but as a single breath. Inhale, exhale. Now gently ask, why does the universe exist at all? The universe is a riddle wrapped in starlight. It spins galaxies like delicate clockwork, ignites suns in the void, and cradles life in its palm. Yet beneath this cosmic dance lies a mystery so profound it humbles even the boldest minds. How did something emerge from nothing? Why is there a here instead of an eternal nowhere? For all our science and stories, the answer lingers just beyond the horizon of understanding. Let's begin gently with the scientific tale we know best. Nearly 14 billion years ago, the universe burst into being in a fiery flash we call the Big Bang. Matter, energy, time, and space unfurled from a singularity, a point of infinite density. But what sparked that spark? Some say it was a quantum fluctuation, a ripple in the void where particles flicker in and out of existence. In this view, the universe is a cosmic accident, born from a momentary shiver in the fabric of nothingness. Others imagine a multiverse, a froth of infinite universes, each with different laws. Ours, by chance, allowed galaxies and life to bloom. Yet these theories only push the question deeper. Why does the quantum void exist? Why does the multiverse stir with possibility? Here's a wonder. The universe is exquisitely fine-tuned for life. Alter the strength of gravity by a hair, or tweak the charge of an electron, and stars would never form, atoms would never bond. For some, this precision hints at a deeper order, a cosmic composer tuning the symphony. For others, it's mere luck, a roll of the dice in an infinite casino. But the question remains, why is there a casino at all? Ancient cultures answered with myths. The Norse sang of a world born from the clash of fire and ice. The Aboriginal Dreamtime spoke of ancestral spirits sculpting the land. Hinduism envisioned Brahma breathing universes into existence, each a fleeting thought. These stories, rich with metaphor, remind us that the urge to explain our origins is as old as consciousness itself. Now let your mind wander through philosophy. Leibniz, the 17th century thinker, asked, "Why is there something rather than nothing?" He imagined a sufficient reason, a divine necessity for existence. Modern philosophers propose simpler truths. Perhaps the universe exists because nothingness is unstable. A void might yearn to become something, like silence aching to break into song. Or consider this: the universe exists because it can. In the realm of quantum physics, every possibility blooms into reality. Our cosmos might be one note in an endless melody, played by the laws of mathematics. But who wrote the score? As our journey slows, let's rest in the mystery. Science illuminates the how, but the why remains a lantern in the fog. Perhaps the universe exists to ask itself this very question. Or maybe existence is its own answer, a gift without a giver, a story without an author. There's beauty in not knowing. The mystery invites us to marvel, to connect, to feel the weight of our smallness and the grace of our curiosity. You, here now, are the universe contemplating itself, a fleeting spark in the dark, yet part of the very fabric you seek to understand. Why do we experience déjà vu? Let's wander into the labyrinth of the mind, where fragments of memory and moments collide in a dance of familiarity and mystery. Imagine stepping into a room you've never entered, yet feeling certain you've stood there before. Our journey begins with a question that haunts the edges of consciousness. Why do we experience déjà vu? Déjà vu, French for already seen, is a whisper from the subconscious, a fleeting sense that the present has already been lived. A conversation, a street corner, the tilt of a stranger's smile suddenly feels like a scene from a forgotten dream. For centuries, this phenomenon has been draped in mysticism, a glimpse of a past life, a glitch in the matrix, or a trick of the soul. Science, however, offers gentler truths, etched in the folds of the brain. Let's unravel this gently. When you experience déjà vu, your brain is not recalling the past. It is momentarily confusing the present. One theory suggests it's a hiccup in memory processing. As new experiences are filed into long-term memory, a millisecond delay might trick the brain into feeling the moment is old. Imagine a librarian shelving a book before you've finished reading it, creating the illusion you've read it long ago. Another idea points to the medial temporal lobe, where the hippocampus and amygdala collaborate to map reality. When a new scene overlaps with a fragment of a similar memory, a layout of a room, the cadence of a voice, the brain misfires, stitching familiarity onto novelty. It's not prophecy, but a momentary tapestry of echoes. Here's a wonder: déjà vu peaks in young adulthood and fades with age. Scientists believe it's tied to the brain's pruning phase, a time when neural pathways refine, occasionally crossing wires. Epilepsy research adds another layer. Seizures in the temporal lobe can trigger intense déjà vu, suggesting the phenomenon is a spark of electrical chaos quickly contained. But not all explanations are clinical. The ancient Greeks saw déjà vu as proof of reincarnation, a flicker of a prior life. In 1876, philosopher Émile Boirac linked it to paramnesia, a folding of imagination and memory. Carl Jung called it a ripple in the collective unconscious, where shared human memories blur with personal experience. Now, let your mind drift. Have you ever wondered if déjà vu is a nudge from the universe, a sign you're exactly where you're meant to be? Or perhaps a reminder that time is not linear, but a river with eddies and bends? Some cultures interpret it as a call to pause, to heed intuition. Others see it as the brain's gentle rebellion against the mundane, a spark of poetry in the ordinary. Consider this. In virtual reality, experiments users report déjà vu when digital landscapes mimic real ones. The brain, it seems, is a relentless pattern seeker, weaving coherence from chaos. A flicker of recognition, even false, comforts us, a reminder that we are the authors of our own perception. As our journey slows, let's rest in the beauty of uncertainty. Déjà vu is neither prophecy nor flaw, but a testament to the mind's complexity. It reminds us that memory is not a ledger, but a living, breathing thing, malleable, mysterious, and tinged with magic. Perhaps the answer lies not in solving the riddle, but in savoring it. Each déjà vu is a fleeting bridge between the known and the unknowable, a reminder that even in familiarity, wonder persists. Why do whales sing? Let's dive into the liquid shadows of the ocean, where sunlight fades and sound reigns supreme. Imagine a melody drifting through the deep, a rumble, a moan, a cascade of notes too vast for human ears to fully grasp. Our journey begins with a question that echoes through the blue. Why do whales sing? Whale songs are the symphonies of the sea. For centuries, sailors whispered of ghostly voices in the waves, unaware they were hearing humpbacks or blues. These songs can travel thousands of miles, bending around seamounts and slipping through trenches. But why do these giants, the largest animals to ever live, pour such effort into music? Is it love, navigation, or a language we've yet to decode? Let's unravel this gently. For male humpback whales, song is a serenade. During breeding season, they gather in warm, shallow waters, each crafting complex areas to attract mates. Their songs, lasting up to 30 minutes, repeat for hours, rhythmic pulses, groans, and squeaks arranged in patterns as intricate as poetry. The most compelling singers often win the favor of females, their melodies a testament to vitality and creativity. But there's more. Whales also sing to map their world. In the pitch-black depths where light falters, sound becomes a beacon. Low-frequency calls can traverse entire ocean basins, helping pods navigate, find food, or reunite across vast distances. A mother's song guides her calf through the dark, while lone whales may sing to signal their presence to others. Here's a wonder: whale songs evolve. Each population shares a unique dialect, passed down and reshaped over years. A pod near Hawaii might sing a tune entirely different from one near Australia. Yet occasionally a new melody emerges and sweeps across the ocean, adopted by whales thousands of miles apart. It's as if the sea itself is a living music hall where humpbacks compose an ever-changing symphony. Indigenous cultures have long revered these songs. The Maori of New Zealand tell of Tohora, the whale ancestor whose voice shaped the islands. Inuit legends speak of whales as wise beings who taught humans to survive the Arctic. When scientists first recorded whale songs in the 1960s, they were stunned by their complexity, proof that non-human minds could craft art. Now, let your mind drift. Can you imagine a sound so powerful it vibrates through your bones? Blue whale calls, deeper than a thunderclap, resonate at frequencies felt across continents. Or the bowhead whale, whose songs span hundreds of distinct phrases, a repertoire unmatched in the animal kingdom. What stories do these ancient creatures tell? Secrets of migrations, warnings of storms, or simply the joy of existing in the blue? Yet human noise, ship engines, sonar, drilling, threatens this acoustic world. Whales, reliant on sound, must now shout to be heard. Some fall silent, others strand themselves, their navigational web disrupted. Conservationists race to quiet the seas, preserving these songs before they fade into legend. As our journey slows, let's rest in the mystery. Whale songs are more than biology. They're a bridge between species, a reminder that beauty serves no purpose but to exist. In their haunting refrains, we hear echoes of our own need to connect, to create, to belong to something greater. Perhaps the whales sing because they can, because the ocean's heart beats in rhythm with their voices, and because, in the end, a song is its own reason. Can time travel ever be possible? Let's drift beyond the edges of the clock, where seconds stretch into eons, and the past and future ripple like reflections in a pond. Imagine standing at a crossroads of time, where every path leads to a different now. Our journey begins with a question that has tantalized dreamers and scientists alike. Can time travel ever be possible? Time travel is a paradox wrapped in starlight. We journey forward every moment, our bodies and minds carried by time's current. But what if we could swim upstream, revisit yesterday, or glimpse tomorrow? The idea has fueled myths and equations, from H.G. Wells' The Time Machine to Einstein's relativity. Yet for all its allure, time travel remains suspended between science and speculation, a maybe, a might be, a whisper in the cosmic wind. Let's unravel this gently. Einstein taught us that time is not a river, but a fabric, a dimension woven into space, bending around mass and energy. Near a black hole, where gravity warps space-time, clocks tick slower. Astronauts orbiting Earth age a fraction less than those on the ground. This is time dilation, proof that time is malleable, but bending it into a loop? That requires steeper curves. One hypothetical path is the wormhole, a shortcut through space-time, connecting distant moments. Imagine folding a piece of paper so 2 points touch. Traversing a wormhole could, in theory, bridge centuries. Yet these cosmic tunnels demand exotic matter, substances with negative energy, to stay open. Do such materials exist? We do not know. Wormholes remain mathematical phantoms, glimpsed in equations but never in reality. Another possibility lies in cosmic strings, infinitely dense filaments from the early universe. If two strings raced past each other at near light speed, they might twist space-time into a closed time-like curve, a path looping back on itself. But cosmic strings, like wormholes, are theoretical wisps, untethered to evidence. Here's a wonder: time travel to the future is already happening. At 99% the speed of light, a decade-long voyage would return you to an Earth centuries older. This is relativity's gift, a one-way ticket forward, paid in velocity. But the past? That's trickier. The universe seems to guard it with paradoxes. If you went back and altered an event, would you erase your own existence? Or spawn a parallel timeline, branching like a tree? Quantum physics offers a glimmer. In the microscopic realm, particles like electrons exist in multiple states at once, a superposition. Some theorists suggest entangled particles remember their past interactions, hinting at retrocausality, effects preceding causes. Could this quantum ambiguity open a door to the past? Perhaps, but scaling such phenomena to human scales is like weaving a tapestry from spider silk. Now let your mind wander through history. Ancient myths whispered of time's fluidity. Hindu texts described cyclical ages, each ending and rebirthing. Norse legends spoke of Yggdrasil, the world tree, connecting past, present, and future. Even Plato imagined souls recalling past lives. Today, physicists like Kip Thorne and David Deutsch write equations where time travelers attend their own birth or leave clues in ancient artifacts. Yet nature seems to resist. Stephen Hawking proposed the chronology protection conjecture, a law preventing time paradoxes enforced by quantum forces. When we try to build a time machine, the universe might crumple the blueprint. As our journey slows, let's rest in the mystery. Time travel captivates not because it's possible, but because it mirrors our deepest yearnings. To undo regrets, relive joys, or witness history's turning points. But perhaps time's arrow flies one way to teach us reverence for the present, for the fragile now. What if time travel is not a machine, but a mindset? A way of seeing every moment as infinite, every choice as a ripple in the cosmic pond. The past lives in memory, the future in imagination, and the present, the present, is the only place we truly inhabit. Why do we age the way we do? Now, we're drifting into a question as old as life itself. Picture a newborn's first breath, a burst of infinite possibility. Now, imagine the soft lines on a grandmother's hands, each crease a map of time. Aging is the quiet melody humming beneath every heartbeat, a process so familiar yet so deeply mysterious. Why do our cells, once vibrant with renewal, gradually slow their dance? Why does time etch itself into our bodies, our memories, even our DNA? Let's wander together through this enigma, where biology meets poetry and science whispers secrets older than the stars. Our story begins not in a lab, but in the ancient forests where life first learned to survive. Evolution, that patient sculptor, shaped aging not as a curse, but as a compromise. Imagine our ancestors, creatures fighting predators, famine, and infection. In such a world, living forever wasn't necessary. Natural selection favors genes that help us thrive just long enough to pass them on. Over millennia, traits that aid early survival might harm us later, like a gene protecting young hearts but stiffening arteries with age. This is antagonistic pleiotropy, a gentle reminder that life is a balance of trade-offs. Can you hear the echoes of those primordial struggles in your own bones? Zoom closer now into the shimmering universe within a single cell. Here, tiny clocks tick. Telomeres, the protective caps on your DNA, shorten each time a cell divides, like a pencil eraser wearing down. When they fray, cells enter a twilight state called senescence, whispering signals of inflammation. Yet some species cheat time. The bowhead whale swims Arctic seas for 200 years. The hydra, a freshwater creature, regenerates endlessly, untouched by age. What do they know that we don't? And what of the mitochondria, those ancient powerhouses, born from a merger between cell and bacterium billions of years ago? They spin energy for us, but over decades, their sparks of respiration rust our tissues, a slow oxidation, like an apple browning in the sun. Aging, in many ways, is a story of accumulation. DNA snaps under ultraviolet light. Proteins misfold. Errors pile up like unread letters. Yet our bodies are not passive. Enzymes stitch genes back together. Antioxidants neutralize molecular shrapnel. But with time, the repairs grow slower, less precise. Imagine a gardener tending a vast wild garden. Eventually, even the most diligent hands grow weary. Here's a curious twist. Starvation in moderation might extend lifespan. Creatures from yeast to mice live longer when calories are scarce, as if scarcity whispers, conserve, repair, wait for abundance. Could fasting be a dialogue with our deepest survival codes? For centuries, alchemists sought the elixir of life in shimmering potions. Taoist sages practiced breathwork to harmonize with eternity. The Greek philosopher Aristotle pondered aging as the cooling of the vital heat. Yet in Japan, the cherry blossom's fleeting bloom became a symbol of beauty. Because it fades. Aging, in all its paradoxes, binds us to the rhythm of nature, to seasons, tides, and galaxies spinning in slow, infinite arcs. What if aging isn't a flaw, but a cosmic lesson in letting go? Today, scientists test drugs that clear senescent cells or genes that reset telomeres. In labs, roundworms glow with extended lifespans. Human trials explore molecules like rapamycin, once a soil bacterium's secret. Yet immortality remains a mirage. Even if we halt biological decay, would we still be us without time's texture, without memory's patina, love's wrinkles, or the quiet wisdom of loss? Perhaps aging is the price and gift of being mortal, a bridge between generations. As a parent passes a torch to a child, cells too must fade, so newer ones may rise. So let's return to our river, gentle and slow. The question why may never have a single answer. Aging is a mosaic of stardust and entropy, of ancient genes and modern dreams. It's the universe's way of reminding us to live is to change, to grow, to release. As the stars wheel silently above, consider this. Every atom in your body has existed for billions of years. You are both ancient and ephemeral, a momentary constellation of borrowed starlight, learning to glow, and then to let go.